Hey, welcome everyone. We're here today for the webinar on Powercalc's real-time one-line diagram. We want to welcome everyone. We're really excited about the launch of our latest application. We hope you'll enjoy today's webinar and learn a lot about it. It's designed by an electrical engineer for other electricals. And so what's going to happen today, James Khalil, our president, is going to demonstrate the one-line diagram, and he's going to show you how the one-line diagram has worked throughout the design process. We're going to ask that you save your questions to the end, and then we'll be happy to answer all of them. You can ask us questions about anything. We'd like this to be a really open forum. You can ask us about Powercalc, the one-line diagram, the NEC, any particular problems you're having with any of your electrical projects, any questions you have. We have a chat box. You can ask them through the chat box. If you're having problems hearing us, please let us know.
Good afternoon, everybody. My name is James Khalil. We're here today to show you the new invention or the new add to Powercalc, the automated generation of the one line in real time. Before we go there, we're gonna start from the ground up on a particular project. So to start a new project, you just access your account. You see here at the top the enterprise company, the name of the company, and then below the gray ribbon, there are several buttons. One of them is a new project. You click on the new project, and that will give you a pop-up screen to input the data about the project. So we're going to call this project here for the time being test. You can also add the project number and the name of the client, Powercalc, and then click on create a new project. Now the system is creating the project for you, and it opens up with this project information sheet, which you can go here and edit the name, any of these input that you input already, or you can add more about the project title, the square footage, and some of these data that you would like to have on the entire project. Now, once you do that, now we're going to start our project. You click on the control panel up here. You can see that the sheet is totally blank because it's a new project. So let's assume some parameters about this project here. We're going to make it very easy and simple, that it has one distribution panel, two panels, and a couple of mechanical equipment. To start the project, the panel, click on the plus button next to the type of the panel. Here's a distribution panel. And to open that panel, you click on it. And here's the layout of the panel. You can set up the panel now, or you can wait, and you can just, as you input the information, it will actually generate all the parameters that define this particular panel later on. As you see, all of them are right now is blank in terms of the main ratings and the feeder and those sort of things. Now, to add the other panels, you go back to the control panel and say we're going to add a lighting panel. So you click on a panel and say that we have a couple of panels. So now we're going to go to that panel, open it up. And again, here's a lighting panel. We're going to go ahead and set up that panel for more circuits. You click on the control panel for panel 1. You see the buttons on the right of it that will identify to you what you can do with that particular panel. Perhaps the most important one is the two wizards that we have in here, the wizard for the panel module and the wizard for the branch circuits. Now we're going to be set up the panel in terms of the voltage and the number of spaces. You go to the wizard panel module. You see the general information up here, with the name of the panel and the units to be used. and the phase right now of the panel is off, but you can set it on if you want to in here. The panel board characteristics, the most important thing would be the voltage. So you can go ahead and adjust the voltage as suits the project. So let's assume that this panel is 480. You click on 480. So now it's going to be set on 480. And then you go through all these ribbons, and to adjust the number of the poles, you go to the panel features and say this panel is going to be of 42 spaces, and then close and calculate. It's going to open 42 spaces for you on that particular panel. Now you notice it took a little while here. It depends on the speed of the internet, because everything is in the clouds. So now we have a panel that is rated for 480 to 77, and it has 42 spaces. As we always advertise about the project, about the program, all I need from you to identify a circuit is 3 inputs. I need to know the kVA. So we're going to go ahead and put 3 kVA. And then I need to know the number of poles for that circuit. You can go ahead and identify, select from the pull down menu. So it's a single pole circuit. And then the type of load, or what we call it, the MAC load. We're going to assume that this load here is lighting. So we're going to go ahead and select the appropriate macro for lighting or power or heating. So I'm going to go ahead and select the power, and then click on calculate. It will calculate that particular circuit for you. So this particular circuit, the 3 kVA, single pole, it's a power. It calculated the trip for you, the trip M on the circuit breaker, and it requires on the branch circuit in here 1 set of 2 number 12 conductor and a number 12 ground in a 1/2 inch conduit, and calculated the voltage drop and the maximum distance for that particular voltage drop. The default for the voltage drop, it splits 2%. The total is 5% as required by the code. Not required, actually, as recommended by the code, I should say. And it's 2% on the feeder and 3% on the branch circuit. So that particular circuit, you can travel 576. If everybody can see it, I'm going to enlarge a little bit. You see that it's 576 linear feet for a 3% voltage drop. Okay. Now let's go ahead and make it smaller again a little bit. And you do that circuit by circuit, and you just put it into the panel. And once you add all these circuits, the system will go ahead and generate the feeder for you. So right now, the feeder for that particular panel, based on this one circuit, is 4 number 12 and a number 8 ground in a 1/2 inch conduit. Of course, that's too small for a feeder panel, but as you add more circuits to it, you will see a larger feeder automatically calculated for you. Now, so that's the concept of Powercalc. Start from the bottoms up, circuit by circuit, input it into the panel. The panel will be generated, and the panel will be generated, and then you can go ahead and develop your power distribution system. So this particular panel, now we're going to say that it's going to be connected to the distribution. So all you need to do is to go into the header of the panel and say that this panel is connected, say, to DP1. It would be subfed from DP1. All you have to do is find that panel and click on it. It will give you move that out of the way, the available circuits to connect that panel 1 So we're going to select circuit number 1 and click on submit. I guess the internet is cooperating today. Here you go. Go back to the control panel. If we go back to panel 1, we just have to refresh for whatever reason. I'm not sure what it is. So I'm going to connect it again with panel 2-panel DP1, circuit 1, submit. It's too many things, I guess, happening at the same time. All right. Let's see if it's going to happen now. Let's do one more time here and see, maybe third time is a charm. Okay, let's select circuit 2. Okay, so we're going to assume there's something wrong here with the internet. So I'm going to take you to a preset project to show you how it's going to be connected and when you're done with your project. So I'm going to go back to the projects and select a project that we already worked on. It's Atlantic West Elementary School. Again, when you start the project, it starts with the project information, so you know which project you have accessed right now. We'll go to the control panel, and here is a preset project that consists of an MDP, or what we call the FPL bus, and then distribution panels, and building equipment. Now, this is a particular project that we worked on with the school, with the Broward School District here in Florida, which is a renovation. So what we've done, actually, we went to the project site with the as-built in hand, mapped the entire power distribution system in that particular site, and then came back and input the information that is as-built to match the as-built condition. That helped us in the renovation, that we need to go ahead and establish the baseline of what is there, so we know what can be done as we move forward with the new design and the modification and so forth. Now, the purpose of this particular seminar that we have today is the introduction to the one-line diagram. So now I have all the panels, all the equipment associated with that particular project, and it also indicates to me how is the power distribution has been developed and indicated, or as indicated on the one-line diagram. So I click on the one-line diagram. It is a picture of the one-line diagram as we have designed it and got the information and input it into Powercalc. If you see now, if I read the one-line diagram from the bottoms up, see like panel L1 is connected via transformer to panel L5. L5 upstream is connected to MDP. MDP upstream is connected to the main incoming service, and we call it FPL bus. FPL stands for Florida Power and Light, which is the incoming service into the school. Or if you start from the top, you see that circuit number 1 on FPL is connecting panel L. Panel L feeds TP3 and also feeds transformer transformer T1. Transformer T1 panel feeds a panel named P and a panel named M. All of that again happened as we input the circuits in each of the appropriate or the respective panels, and then we make the interconnection, as I'll try to demonstrate with the new panel, but I'm going to go ahead and demonstrate it in here. So we go back to the control panel. Oops, there you go. If I click on, say, MSB here, MSB consists of a one circuit on it, which is rooftop unit number 1. Where did that rooftop unit come from to this particular panel? If I click on rooftop unit number 1, it would take me to the input sheet, data sheet. So here is rooftop unit number 1, and it's fed from MSB circuit number 1. And then we'll put the parameters of that particular building equipment in here. It's a motor, and it's rated for 84 kVA. And then we go here, fed from, and we selected MSB. And that's what I was trying to do on the startup project. So I'm just going to go ahead and take it out, and then I'll show you. So now it's not connected to anything. So I will go back and connect it to MSB. It would tell me which circuit. I'll select number 1, and we say submit. Let's see if the internet's going to work this time. It worked. Okay, lucky. So MSB, I'm sorry, rooftop unit number 1 is connected to MSB circuit number 1. So go back to see if it reflected back into the one-line diagram. I go back to here and click on one line. We'll find MSB. Here's MSB, and here's rooftop unit number 1 with the over-counter protection device. Okay. Now, one of the options that we have in here is how you display the circuit parameters or the circuit values associated with any of these circuit breakers and any of these panels. It varies from one municipality to another. Some municipalities allow us to go ahead and have a table. So we have a tag for that particular circuit. It's number 22. So let me also zoom in a little bit. So it's circuit number 22, and then here's the table, the feeder table associated with it. You go ahead and scroll down to circuit number 22. It's number 12 and a number 10 ground conductor. The other option is that some municipalities, especially here in Florida, they will not accept it unless we have the conductor size next to the conductor representation for it. So we have an option here that you go option, hide the legend. And I also have an option here to change the font size if you want to. So I can go ahead and change it, say, to 24, apply the changes. Okay, so if you notice if I get your attention back to rooftop unit number 1, it took the tag designation 22 and listed the actual conductor size and enlarged the font a little bit more for to be legible. Okay. Now, so as you can see, it's all is happening in real time. Now, let's say that we're going to go ahead and connect another piece of equipment to MSB. Okay. If I go to here, and another button that is very important, I guess, is the PDT. Sorry about that. I'm sorry. The project distribution tree in here, it will show you the tree of how the system is being organized. On the left side here, it shows the FPL bus, which is what is connected to the one-line diagram. Now, in here you see one important thing, it says unlinked panels. Okay, so what this says in here that you have input into the system, these particular equipment and panels, but you have not connected them yet to the overall one-line diagram. So that will give you the chance, because sometimes you could be, first of all, unaware that you connected these pieces of equipment, or also that you need to make a decision where they are to be connected to. So let's say that we're going to go ahead and connect air handling unit number 1 to MSB. So we'll go back to our enterprise. So air handling unit number 1, here it is. I'll open it. And again, we input the information based on the values that we got from the site. So this air handling unit is only have a motor at 1.5 horsepower, and it calculates for you the feeder and the load and everything. Again, I'm gonna need to move this away.
Hey, I'm Ken with Home Run Electric.
Yes.
I don't have the PDT option on my program.
I will look into that. You should really have it. So maybe when we send you the link to it, because you were an upgrade, right?
Yes, sir.
Yeah. So maybe we just did not switch that particular option on your upgrade. But I'll make sure that my assistant will make a note of that, and we'll get you that one. Okay.
Okay, that's great. Right. Now that'll allow me to do meters and things.
That is correct.
Oh, awesome.
Yeah. Okay. All right. So now we are on the air handling unit, and you can see again under fed from it says select. So really it's not connected to the power distribution. And as I said, we're going to go ahead and connect it to MSP. So I'm going to go ahead and say connect. Again, it gives me a list of the available circuits. I'm going to connect to circuit number 3. If I go back to the control panel, click on one line diagram, a little bit. So here's MSP. Remember, it was only rooftop unit number 1, and we just connected air handling unit number 1 to it. And here it is with all the parameters that support that particular load. Now, the same method can be used if you decide to say, you know what, no, MSB does not feed air handling unit number 1. Actually, air handling unit number 1 is fed from MCC control panel. So again, I go to the application, go to air handling unit number 1, go to fed from, take that out, and then select it again and go to MCC. So I'm going to click on MCC. Again, it gives me the circuits that are available. I'm going to put it on circuit number 6 and say submit. Go back to control panel, go to one line. Okay, so here's MSB. The circuit number 3 is gone. If I go to MCC, now it's circuit number 6. Here it is, air handling unit number 1. Now, also in that process, if the parameters or the values of MCC need to be changed or adjusted, it will go ahead and go all the way, adjust the overcurrent protection device in here, adjust the conductor size for you automatically, and it will actually take it all the way upstream. It will adjust all that for you, unless you have set these values to be constant or to be took out the automatic calculations from it. So, and also probably reduce MSB upstream until it reach the FPL. So, and if you see that everything is happening in real time, and it will adjust it for you automatically and update all the information from that particular point all the way upstream to the point of service. All right. Now, if the load changes, so again, let's take, I'll put our concentration on rooftop unit number 1. It right now is protected by a 30 amp 3-pole circuit, and the feeder is a number 12. So we're going to go back to rooftop unit number 1, and either that the mechanical engineer changed his mind, or when went back to the job site to verify the information more. We might have, got the wrong information, or there's more information available for us. So this particular rooftop unit was 81 kVA. So, oops, yeah. It took me actually to a different panel. Let me see what. A different project. All right. So rooftop unit number 1. MS, took a different project, here's MSB. Okay. And let's say that we've changed the kVA to 150 kVA. So if I go back to here, MSB still at 30 amps. I've opened too many projects here. So let's go back to the project. Okay. Okay, and this is here, okay. Control panel. So I've got 2 rooftop units in here, one that is rated for 30 and one is rated for 250. I just kept it the same here so you can see, once I adjusted the number, it will, the load, it adjusted the kVA, the trip, and adjusted also the conductor size. So again, everything is happening in real time for you. And I guess with that, I would leave the floor for any questions anybody has. Any question, anybody?
Can you show us how you input an existing condition to set up a project for when you're doing a renovation?
Yeah.
Okay. What we have, let's assume that here's the project that we are working on. It's an existing condition. So when we went to the job site, we got the one-line diagram, the as-built, and we go and verify this information in the field, and then we come back and input information. So say that we found that there is another distribution panel. So you come back in here and you click on the plus sign to add that distribution panel. So you see it added distribution panel number 8. And these are the default names that's in the system. So if I go to it and I can go ahead and change to whatever it is. So let's say it was panel DP or panel LA. So I can go ahead and say it's panel LA. Okay. Now, again, based on the information, that since it's an existing panel, we can go and say it's an existing panel. We know it's fed from, say, MDP or MCC or from the bus. So we can go ahead and say it's fed from, say, MCC. Again, it tells me what, or shows me what available for me to connect it to. So say circuit number 7. Now, the other information that you obtain from the field and the as-built drawings is the panel values. So this panel right now, we go to set up the panel values. We need to go to the control panel. And again, as I said earlier, on the right side, it gives you the available options to work with this particular panel. So if you scroll down a little bit, you see that you can print, preview, and so forth. And the most important ones are the wizard panel board module and the wizard branch circuit input. We're gonna go ahead and start with the setting up the panel itself. So again, you have the 7 parameters or 7 ribbons to set up the panel. On the general, it's the panel designation, which I could have actually done it in here instead on the panel schedule itself. And then measuring units, it's on the US. We do have the option to change it into metric, but that's a separate subscription, if you will. The transformers are set on auto. And then again, the pH balance is on. This is to balance between the phases, phase A, B, and C. Again, we're only allowed with the variation of a 5 to 10%, I believe so. Panel board characteristics is the copper panel. If it's aluminum, you can change it into aluminum. And it's set on 480, and we're gonna go ahead and set it at, say, 208. And then leave everything here on auto to do the calculations for you automatically. But since this is an existing condition, and we went to the field and verified and say that the main is actually on the frame is 200, and the main was 175 amp, and it has a main circuit breaker or main lugs only. So I'm going to go ahead and say it's a main circuit breaker. On the feeder, again, you see all the fields are set on auto, but again, it's an existing condition. You can go ahead and say that the gauge is, I guess it should be about maybe a 4 odd to support a 200 amp, or maybe a 3 odd to support the 150. The ground gauge, again, whatever it is, you can go ahead and set it up, or leave it on automatic, and it will actually find out for you automatically what is the appropriate ground conductor associated with a 4 odd conductor. The conduit size would be the same thing. You can leave it on auto, or if you know exactly what it is, you can go ahead and select it. And then down here, the panel board features, there would be the number of circuits. So say it's a 24 spaces, you type 24, and then now I need to move this away. All right, so now we preset the panel to match existing condition. So it's a 208 volts, 120, and everything that you set up manually, it shows it in red as a flag to let you know that you have taken the auto feature away from the program. So that panel frame is 200, 175, main circuit breaker, and the conductor is 4 odd. And it figured out to you the NEC requirement for that particular panel. It needs a number 2 ground. All right?
Yeah, could you tell us what's the auto setting?
The auto, there are, I think there's about 300 parameters that we have in the program that it changes these, which reacts to the amount of load that you input on the panel. Some of these are the frame, the main ratings, the number of the sets of the conductor number, the wires, the size, the gauge, the ground, the conduit, and so forth. So you set them up on auto when you start a project, so it will go ahead and do that for you as you input, and the value of the KVA is increased as seen by the panel. It will go ahead and adjust these values automatically for you. And we are the only one that do that. Others are they preset the panel, these values that we call them automatic values. It's preset. So if you preset it, say this one here, we set it on 175, and you keep inputting information into the load into the panel, you may exceed that setting, and they don't give you a warning. They don't let you know that you have exceeded that value, meaning that that particular panel is way overloaded, and it's not going to be protected by that particular circuit breaker. So we are the only one who set up this information on auto, and will actually adjust it as you input the load into the panel. Okay. Any other question?
No, can you continue to show us the renovation project?
Okay, so now, we set up the first panel. Now, now you go ahead and fill up these panels circuit by circuit to match the existing condition. I'm just going to go ahead and just put a few circuits here. Now, you can do that two ways, either directly on the panel, circuit by circuit, or the recommended practice would be actually going through the wizard. So to access the circuit wizard, again, you go to the control panel, and then you click on the wizard branch circuits, and it will give you a window where you input circuit by circuit. So right now I'm in panel LA, and I can select the circuit number. Of course, it took me directly to number 3 because we have already input values in number 1 and 2. So now it's telling me that number 3 is the next one available. So it's circuit number 3. Load description, let's say receptacle. Okay, and it's 2 kW. Select number of poles, it's 1. Load type, we're going to select R for receptacle. Here's R. So it already displayed to you what the branch circuit is going to be automatically. All these are automatic values. So it's one set, two number 10 conductor, and a number 10 ground, and a 1/2 inch conduit. Okay, and that's all what you need to do. All I need from you is the 3 inputs: the load KVA, the number of poles, and the load type. Now, why the load type is important? The load type is important because there is a differentiation in the NEC between a motor load, a resistive load. So you need to tell the system what it is. Is it a resistive load, or is it a motor load? If it's a motor load, you would select M from the 4 M's option that you have. Okay. If it's just a power load, like a heater or something like that, you go, or a water heater in a residential, you select the letter P. All right. And now to go to the next circuit, you go ahead, new circuit. Now circuit number 2, again, all I need from you is the 3 inputs, and let's say it's 6 kW, number of poles is 3. And the load type, let's say it's an M. Okay, Ethernet. And we're going to select M1. Okay, now all these values is going to be populated in a little bit. Okay, or we can go ahead and close and calculate. And if I go to the panel, here's the circuit number 1. Oh, this one I forgot to say what it is. I can go ahead and go in here if I want to, air handling unit. And I can also input it here. Is there a question?
And what happens if you want to change a value?
Okay. And I can calculate. All right, so it calculated the 3 circuits that we input. We input 2 through the wizard and 1 on the panel schedule itself. Okay, so these are the 3. Again, let's move this away. Okay, so let's say this is here is a condensing unit. So we'll. All right, now again, as it happens, and everybody knows that, mechanical probably is at the last minute is going to go ahead and change their mind about the mechanical equipment. So let's say now, I don't know, 5 o'clock is the deadline today to issue the drawings. The mechanical comes to you at 11 o'clock in the morning and said, oh, by the way, I changed my mechanical equipment in here. Now, in the old way, well, I have to go ahead and recalculate everything from the circuit all the way upstream until I reach the MDP. But here I can just go here or go again to the wizard and change that value to a 12. Calculate. Voila, it changed everything for you all the way from that particular circuit all the way upstream. And updated the 1-line diagram for you and everything. And all you have to do now is print and ship out of the office. And you did not miss the deadline, and nobody's blaming you that it was because of you, electrical, we had to go ahead and miss the deadline. All right? So you do that for each panel under that existing condition. And then once you connect it to the power distribution system, as we illustrated earlier, okay, this particular panel is connected to MCC 7. So if I go to the control panel, go to the 1-line diagram, and if we go to MCC 7, I'm sorry, MCC, here is my panel. I don't know why I didn't see it. Am I in the correct one? Let's take this out.
Okay. You're gonna have to repeat the number. I was getting a call.
MCC 7. Yeah, it's panel LA. It should be on the 1-line diagram. Let's go back to the 1-line diagram. On circuit number 7, here is panel LA. You see it? Let me get it up here. Okay. So panel 7, circuit number 7 is panel LA. And it showed also all the circuits that you have on panel LA down here. Okay. Any other question?
Yeah, how does Powercalc comply with the NEC?
All our calculations are based on the NEC. So we are 100% compliant with NEC. Now, what does that do to you as a design engineer, contractor, or designer? Now you have a design that is matching I guess a jurisdiction requirement. So if you ever get sued, audited, or whatever, at least you have something to rely on and say, yeah, it's as required by the NEC. Also, it gives you the most economic, cost-effective, and economical design. There is no over design, there is no under design, there's no over values or under value. This is exactly what the NEC is telling you to do. So engineering wise, it does its own calculations based on the engineering and the power requirement as electrical engineering. And then it go and match your calculations, the amperage, the overcurrent protection device, the conductor size with the NEC. So it gives you the most economical way or most economical design that you can obtain. Now, you asked earlier about the auto function and what also it does for you kind of thing. So one of the other reason we have the auto and the manual, some engineers will have their own preferences in when they go ahead and design. So even though that the NEC is giving you the minimum value, some engineers go ahead and play it safe, say, you know what, instead of a number 12 conductor, I want it to be a number 10. Fine, go and take out the automatic calculation and put it on a number 10 conductor or number 4 or whatever you want it to be. Now, once you do that, if you change the conductor size, it will go automatically and change the conduit size for you, the ground conductor size for you, all things associated with that particular change or one item change. So we are complying with the NEC. And every 3 years, NEC issues the new update. So we go back and adjust our database to match the updates. So you're always going to get the most current values that matches and match the NEC. Okay.
Yeah, we talked about a renovation design. How does Powercalc work in a new project, new build?
It's a little bit easier. It's almost the same process. This is just a little bit easier. That you don't have any existing values that you have to be abide with or anything like that. So again, set up the panels and the distributions and the main, and then interconnect them as you go. And also leave everything on auto. And all I need from you, or all the program needs from you, is, as we discussed before, is the 3 inputs: the kVA for the load type, and the number of poles. And then let the system do its thing for you. Connected, connected upstream, downstream. You can connect a panel to a panel, and a panel to a distribution to the main distribution, a distribution panel to another distribution panel. Building equipment, you can connect it all the way from a panel to a distribution to the main distribution. You can move them around as the project is progressing. And you made a decision that, like we did in here, panel LA is fed from MCC. Say you figured out a more economical way, really, instead of connected to MCC, I need to connect it to panel KH. You can go ahead and do that with almost a click of a button, and the whole entire system will be adjusted automatically for you. So it's as simple as it can be, and it's not really modifying your in-house process. All it did really is automated that process for you. You always start from the circuit, put it in the panel, and then you add all these circuits together and come up with the size of the panel, and then you go ahead and make a decision that this panel is connected or fed from this distribution panel, and then you go and adjust the distribution panel. So it really augmented that process, everyday process that you go through, and instead of spending days and months on it to do that particular project or to design that project, it cut it all down to about 40 to 60% of the time used conventionally to do these projects. And now with the, I'm sorry?
I was just wanted to make a comment that I started using this program not too long ago, and I'm not very computer savvy, and it's really amazing at how simple you've created and how easy to use and user friendly. And you've done a great job on it. I look forward to doing more with the one line. I haven't got to do much with it yet, but the low calc portion has been great. I would recommend it to anyone.
Great, thank you. That's really the goal for Powercalc, is to have happy customers like you, and is really to make your life easier and give you a higher or a much higher quality project and information that you can actually stand by and defend it, that it's correct, accurate, and it's the most economical way to do it. Thank you very much.
And I just got my my first set back from Seattle building department, and 0 corrections on the project. It was nice.
Great, thank you. Great. And hopefully, we can also, by feedback from you, let me know what you would like to see in the drawings, or even if you ever get a comment, I guess, we can always adjust the system to meet most of these requirements. So
yeah, they're great. I've got a few things that I'm going to look at and talk to you at the appropriate time. Like breaker options.
okay.
Now we have dual function breakers. Hit the market the last couple of years, so it would be nice to have that option.
Okay. We will look into that, and we'll see what we can do to include these options.
Okay.
Great. Any other question? I think we're coming very close here to the end of the hour. So I really appreciate everybody's time. And the next seminar or webinar is going to be about the other calculations associated with the one-line diagram. Things that we did not talk about is the voltage drop, the fault calculation, and the equipment AIC rating. So we will move forward to that next time. We'll start where we stopped in here today, and next week or in the next seminar, we will talk about, as I said, voltage drop and the fault and the AIC rating of the equipment.
Okay, that would be next week at the same time?
That is correct.
Okay. I look forward.
Great. Thank you very much. And it's not going to take that much time because now you're familiar with the project and with the program, and you'll be surprised when we execute the fault calculation. It's really a click of a button and I'm done. So it's going to probably take 2 seconds.
Yes, sir.
All right. Thank you very much.
Thanks, James.
Bye-bye.